So in this video, we will learn how to convert a binary number to a hexadecimal number. So here we have an example where we have 4 ones and then 0, 1, 1, 0. So the first step is to group them in groups of 4, starting from the right. That's very important. Always start from the right and group them by 4. The first 4 digits will be these, and the next 4 will be this. And now we need to convert these groups of 4 to decimal numbers. So as we know, 4, 8, 4, 2, 1 and 8, 4, 2, 1, and now we need to find the decimal number. So here we have the ones for 4 and 2 for the right, this one. So and 8 and 1 are 0, so we add 4 plus 2, which is 6. And here we have ones for everything, so 8 plus 4 plus 2 plus 1, which is 15. Now the other thing you need to know is how we represent numbers in decimal to hexadecimal. So from 0 to 9 all the way to 9, they are the same in decimal and in hexadecimal. So let me just write D up here. Oops, yeah, actually let me just move this down. D to decimal to hexa. Okay, and when we come to 10, 10 represents A in hexadecimal, 11 represents B, 12 represents C, 13 represents D, 14 represents E, and 15, which is the last digit, represents F. And as hexadecimal is a base 16 number, a base 16 number system, so meaning there are 16 digits that a digit can have from 0 to 15. So here 15 is F and 6 is just 6. So the final answer would be F6. And you can also write base 16 next to your number, so F6. So now let's do more examples. So here let's start again by grouping them in groups of 4 starting from the right. That's very important. So the first 4 groups will be 1 ones, 3 ones and 0, and we realize that we only have 2 more digits left. So here if we want to convert to decimal, this will be 1, 2, 4 and 8, and since we only have 2 digits here, it's just going to be 1 and 2. So this is the reason why we always start from the right. Since if we started from the left here, it would be 8, 4, 2, 1, 1, 0, 0, 1, and you would have 1 and 1, and this would be, I don't know, 8 and 4 maybe. So that is completely wrong. So always start from the right from grouping them, and now we just add these numbers up. So 2, this is 2, and this one is 4 plus 2 plus 1, which is 7. So the answer would be 2, 7 in hexadecimal base 16. You can also write 16 next to it to represent that it's a hexadecimal number. So in our next example we have 8 ones. So again separate them. So this is the first 4 from the right, and this is the next 4. Now convert these into decimal numbers. So this is 1, 2, 4 and 8. So this will be 12, 14 and 15, and 15 is F, as we know from before, and this is also 15. So the final answer is just F and F, which is the hexadecimal representation of 8 ones, or this binary number. So let's increase the length of our binary numbers. So here we have the first 4, the next 4, and we have 2 more. So let's just add a few more, why not? 1 and 1 here, and let's say 0, 1, and that's it. So this is 15. This will be 8 plus 4 plus 1, which is 13. Yes, and this is 8 plus 4 plus 2 plus 1, not 1. This will be 14. And did I make a mistake here? No, it's fine. And this will be just 2. So 2 is just 2. 14, so it's always best to make this table. So starting from A, which is 10, B, which is 11, C, which is 12, D, which is 13, D, E, which is 14, and F, which is the last one, 15. So here we have 14 is going to be E, 13 is going to be D, and 15 is F. So the final answer is 2E. Okay, my E is, yeah, D and F. And this is the answer. So here is the last question, and if you manage to do this question correctly, then you are a master at converting binary to hexadecimal. So let's start. Actually, let me add few more things over here. Yeah, so 100 and then all these. So starting from the rightmost again, so this is gonna be 8 4 2 1, 8 here, this is gonna be 1, this is gonna be 3, this is gonna be 8 plus 4, which is 12. Here is gonna be 4 plus 1, which is 5. This is gonna be 6 7, 8 plus 4, which is 12, and 14. And this is gonna be 8 plus 10, 8 plus 2, which is 10, and the last one is just 4. Now let's quickly write the conversions because I don't remember it like this. So 12 and D is 13, E is gonna be 14. Yeah, okay, so 4 is gonna stay the same, 10 is A, 14 is E, 7 is just 7, 5 is just 5, 12 is here C, so C, and then 3 is going to stay the same, 1 is going to stay the same, and 8 is going to stay the same. Now as always, I do have a shortcut method to recheck your answer on your calculator. So you need a calculator with a base minus n option menu in your menu button. So it should say or tell you this base minus n, and you go there. And now you click on a button which would say bin, bin, and you type your whatever binary number you have. So here we have 100 1010. I'm typing on my calculator 0111 0101 and then 1100. Okay, I might have made a mistake. Okay, anyways, 0001 and then 1000. Now click on equals to. So actually there is a length or cap on the calculator. So let's go to our previous example. So again, just type your binary number in your calculator and press on equals to, and then you will see a hex button which says HEX on your calculator. You just click on that and then you will get E. It says on my calculator 2E, sorry, DF, and that's a way to recheck your answer, and that's it. It's pretty quick, and in no time it's done. And the limit, I just realized, is for binary is that they can only be maximum of 8 objects. So 4, so basically 8 fours, 8 4 digits in total. And thanks for watching. I will be making a short video on how to do this on the calculator, as it is more easier to see something rather than talking about it, of course. And thanks for watching.